Hello, now we will talk about regression modeling. What regression modeling is? Regression modeling is a statistical and machine learning technique used to understand and predict relationship between variables. It helps in determining how one or more independent variable or predictor affect an independent variable outcomes. First, we will talk about estimation model. This estimation model evolution using Python. Here today we will explore how to evaluate regression models. First we will look at how to access the performance of a regression model using key metrics like mean squared error, root mean squared error, mean absolute error and R squared. Let's get started. Overview of model evolution. Model evolution is crucial because it helps us to understand how well our model perform in predicting the target variables. We use various metrics to access the accuracy of predictions, which include MSE, RMSE, MAE, and R square. In this demonstration, we will use a synthetic linear regression model to predict values based on some random data. So here you can see setup Google Colab environment. We will use exclamatory pip install skikit learn matplotlib cbon. Now code implementation, estimation, model evolution. First see running our code. Yes, the pip installed. Now we will talk about code implementation, estimation, model evolution. Code walkthrough. As shown in the code, we generate synthetic data with a linear relationship and some noise, then split the data into training and test sets. After training the models using the training data, we make prediction on the test data. Next, we calculate the evolution metrics such as MSE and R square to check how well our model performed. So importing libraries, import numpy as np, import pandas as pd, and next generate synthetic data np.random.seed 42x equals to np.random. This splitting the data into train and test sets. Next we will initialize and train the models, and next we will do the predictions. Then estimation, model evolution, and then displaying the result. Print mean squared error, print root mean squared error, mean absolute error, R squared error. Now then we will plot the actual versus predicted values. So we will run our code. Here you can see the graph is plotted, actual as blue dot and predicted as a line. Next we will talk about explanation of the evolution metrics. How the evolution performed. Mean squared error, root mean squared error, mean absolute error. Now next we will talk about the stepwise regression using Python. Let's dive into stepwise regression as a technique used to select the most important feature for a regression model. We will explore both forward selection and backward elimination. Forward selection and backward selection or backward elimination. Stepwise regression work by adding or removing variables in a regression model based on their significance. In forward selection, we start with no predictor and add them one by one, while in backward elimination, we will start with all predictor and remove at the least significant ones. So the code we have in the code we generate a synthetic data set with multiple features, then we apply both forward selection and backward elimination. The result is a list of selected feature data can be used for building the final regression model. Here you can see import asterisk models, generate synthetic data, add constant to the independent variable, convert x to pandas, forward selections, backward eliminations, and run forward selections. Output the selected feature. Now we will run our code. As you can see, there is a selected feature by forward selection, selected feature by backward elimination. Thank you. I hope you have understood the topic.